This is Hope and Health with Doctors Michelle and Mark Sherwood. Insights and interviews with a dose of straight talk to help you enjoy optimal health in all areas of life.
Hey everyone. Welcome to another special edition of Hope and Health. I'm Dr. Mark.
And I'm Dr. Michelle.
We're glad to be here with you. And we're going to continue, kind of in this thing we call Life Series. And hopefully you enjoyed the last week. Boy, that was a lot, wasn't it?
It was a lot. But if you don't know, you can't change what you don't know. And if you don't know what you're made up of or how this temple is made, sometimes taking good care of it can be a little bit of a challenge.
Guess what we're drinking right now? This is Kingdom Fuel.
Fuel.
There you go, which is finally available out there. Oh, it's good too. Obviously, this is chocolate. It comes in chocolate and vanilla. So here's to your health. Really, you got to get a hold of that Kingdom Fuel. That's a big deal because you're not going to be able to really fuel your life, really, if you don't understand Kingdom Fuel. If you remember, last week we began a series that was called the Life Series. And the Life Series was really about a question of life.
How does life work and how is it life built? And we talked about how life comprises each individual, living beings, all the way down to bacteria. Each individual is composed of one or more minimal living units called a cell.
And then we started talking about the anatomy of an organism. And I know that blew everybody's mind. So the anatomy of an organism was, this is how life begins. I mean, this is the basics of life.
And so life exists on Earth because of the following reasons. We know that Earth has all of the basic necessities that are required for organisms to survive. The temperature and the atmosphere of the Earth make life comfortable for the organism. And all living organisms share several characteristics or properties or functions. And these are order, sensitivity or response to the environment, the ability to reproduce, grow and develop, regulate their internal environment, a thing we call homeostasis. They're also able to produce energy and evolve through a process of adaptation.
And of course, then we talked about, the cells, the basic unit of the organism. We started right there. And obviously, we were starting to break down the different parts of the cell. So just by way of a quick, very, very brief reminder, here are really the basic functions of the cells.
The cells, they can build tissue. And we know that tissues actually are what start to build organs. And organs build systems. And all of this combined actually builds an organism. And all of this makes you and I human beings.
So when you think about a cell, it has a lot. Remember, we broke down the cell into three main parts. We talked about all that. And there was three, if you remember. There was the membrane, the cytoplasm, and the nucleus. But the nucleus was right in the center. Remember, the membrane was on the outside, and then the cytoplasm is basically every single thing in between. And we kind of started breaking down the different types of cells. We showed you what a big cell looks like and all of that. That was mind-blowing, I know. And then we went through to begin to talk about the components of the cells. And if you remember, last week, we began by talking about the membrane. And I think we got that far, didn't we?
We absolutely did. And we talked about how the membrane is composed of certain things that encloses the cell. Inside of the cell, again, it is the nucleus, which is at the very center of the cell, which also contains the DNA, the deoxyribonucleic acid, which is really a fancy way of saying genes or genetic material. And we also talked about the mitochondria just a little bit. We introduced that as the powerhouse of the cell, and we're going to dive in deep to the mitochondria at some point.
We'll get there, but I think we got through the membrane last week a little bit, and just a very, very, very quick reminder of the components of the membrane. We want to show you a quick graphic just to kind of get you there, and then we'll pick up our conversation from last week with the nucleus. So here are the components again of the membrane, which is the outer part of the cell.
So up in the far right left-hand corner, you see a thing that looks like a popsicle. That yellow dot is a hydrophilic head, which is water-loving. It's on the outside of the membrane. On the inside of the membrane is a fat-loving or hydrophobic tail, which is connected to another tail that is has a hydrophilic head. These two layers distinguish the outer side of the cell with the inner side of the cell. And as you see in that cell, that phospholipid bilayer, you see channels, things that allow movement of things into and out of the cell. You also see cholesterol components in that cell membrane, as well as glycolipids, glycoproteins, and even carbohydrate chains.
So that membrane, as you can see there, sort of acts like a barrier, but it also allows things to go in and out, which is, boy, that's just brilliant, amazing. So we're going to begin our conversation now. We talked about the membrane last week. This is the outside. And today we're going to pick up talking about the very center of that. Probably some would say it's the brain of the cell, called the nucleus. So let's begin right here where we left off last week with this thing called the nucleus.
So the nucleus is separated from the rest of the cell, called the cytoplasm, by this thing called the nuclear envelope. Now, the nuclear envelope is continuous with the rough endoplasmic reticulum. You can see the nucleus, which is orange. The rough endoplasmic reticulum is kind of like some squiggly blue inside of the cell. The rough endoplasmic reticulum contains ribosomes, and these tiny ribosomes are components that are involved in protein synthesis. So the genetic material of the cell is actually located in the nucleus. The chromosomes, the genetic material, once again, is in the nucleus. And you obtain half of your chromosomes from your mom and the other half from your dad. Your genes, which are composed of DNA, deoxyribonucleic acid, direct the process of making proteins, and then these proteins carry out orders in the process of making new cells, forming tissues, making organs, and organ systems.
And obviously, that's the way we're going to approach this. Once we get done talking about the cell, then we're going to go into the mitochondria because it's a powerhouse. But we're going to talk about how the tissues, what tissues are formed, then what organs are formed, and then what organ systems are performed. So that's what we're doing this. We're going to start from the low end of things, the basics of life, and work outward. It's really cool to think about. So when we start talking about this nucleus, which is the home of the DNA. Remember, 23 chromosomes from mom, 23 chromosomes from dad. The fascinating thing I've always thought about this is here's a cell that's been formed at fertilization, right?
Like two mashed potatoes.
Mashed potatoes, back to our analogy. And this cell has the same DNA as it multiplies, but it actually has the smarts, the intelligence to do what it needs to do to form the different type of tissues, the different type of organs, and the different type of organ systems. That's crazy to think about. So let's get into this thing called the DNA. I think the DNA is one of the most extraordinary things that we talk about. And so you remember, you might see this DNA sort of illustrated with this double helix. So, that might be like a tight wound spiral of things. But there are some things here with DNA basics that we really, really want you to get. And so with these basics, there's a few factors here to talk about.
Well, once again, DNA stands for deoxyribonucleic acid, and it directs the process of the formation of proteins or protein synthesis. It's like a big protein manufacturer. This thing called messenger RNA is actually transcribed or made from your DNA, and once it's made, it then travels through these nuclear pores in the nucleus into the cytoplasm, or the goo that's outside of the nucleus. Messenger RNA is then translated onto those ribosomes, those little nodules that sit on top of the rough endoplasmic reticulum, and this happens by a process that produces proteins. The ribosomes, these are also generated in the nucleolus inside the nucleus, and they travel through the nucleopores to the cytoplasm and house themselves on the rough endoplasmic reticulum. And through the ribosomes, here is the process of replication, transcription, translation, and the regulation of these processes is actually essential for health and human life.
And wow, does that get complicated? I know. But when you think about this, I mean, this is really the core issue of how life's done. The DNA is like this recipe book. It's like a big cookbook, if you will, of the various proteins that you need to have function to create these tissues that need to form organs and organ systems. So everybody's a little bit different. Few people understand that our DNA is only changed 2% in 10,000 years. That's it. It's not much. So that's right. You have the same DNA basically as Noah and his wife did. We do when they hopped off the boat and waded through all the dead stink bodies. I don't know. They were still around, I'm sure.
Yeah.
So the bottom line is that DNA is still around today. What has been really changed a lot is the environment, which has been manipulated, changed, altered so much that now we have the DNA and the environment that sort of don't match. And so I think that's really the crux of why we have diseases. But understanding the way this works is critical. And this is why you don't mess with the DNA. You mess with the environment outside of that. You can change your environment, but you shouldn't change your DNA. Hopefully that makes sense to everyone. So take a quick break. And while you're getting this commercial break, we're going to have our Kingdom Fuel, right? One more time. Here's the Kingdom Fuel. And while you're thinking about DNA, check out this message and we'll be right back.
Hi, friends. Dr. Michelle Sherwood here.
I'm Dr. Mark Sherwood.
Many people know about our clinic, but we also have a desire to help people who can't personally visit us, but still want to take steps towards better health.
Our 2-week health reset is a great first step and requires no video appointments or tests.
With our health reset, you will get 28 detox shakes to provide the ideal nutritional foundation, 28 supplement packs with key nutrients, and access to daily videos where we encourage you along the 2-week process.
Our health reset plan is usually $180. Now, it's just $169 with your promo code. Go to Sherwood.tv now and use promo code HOPEHEALTH to receive this exclusive offer.
Take a simple step and let us guide you on the road to feel better.
We're back, and as we promised you, and promising you this for
months.
It's been months, but here it is. Here's the final product. This is what you've been hearing about. Now, this is chocolate flavor. We've been drinking. We've got vanilla flavor and all this, but we've got both. And so they're really good. You need to think about getting your 3-month food supply right now that's actually a sustainable food supply. Now, this obviously it has a complete protein, vitamin, mineral, greens, reds, fibers. It's got everything. It's a whole fuel.
And why would we think that this is so important? As we talk about the cell, we've showed you the cell membrane. There's proteins, carbohydrates, and fats included in the cell membrane. We've talked about DNA. All of the process of replication, translation, etc., and otherwise are dependent upon proteins, carbohydrates, and fats, and essential vitamins and minerals. Kingdom Fuel is complete. And Kingdom Fuel will also help fuel the mitochondria.
Speaking of mitochondria, here it is right here. And this is what it looks like. It looks like it looks like a man's slipper.
I always thought that was like a jelly bean cut, sliced open. And on the inside of that jelly bean, now you have an outer membrane. And on the inside, you have this thing called an inner membrane. And all those invaginations or those squiggly lines are called the cristae. And on the cristae, lots and lots of cellular processes happen throughout each component of the cell membrane, both inner and outer, of the mitochondria. And even things happen in this thing called the matrix.
Yeah, a lot. And it's not the Matrix, the movie, but it's close. It's wild. But the mitochondria has a lot of things it does. And at some point, not tonight, but at some point we'll get into the actual vitamins and minerals required to fuel the mitochondria. Hence, we have to have the right fuel, Kingdom Fuel, to allow our mitochondria to be driven appropriately, which is cool. So the mitochondria, there's certain basic things you want to know about that.
Mitochondria are kind of like organs. Inside the cell, these tiny little cellular components are called organelles. And mitochondria are an organelle that produces most of your energy. Each little tiny mitochondria, as we talked about, is surrounded by an envelope, which is the outer membrane. It's also composed in an inner membrane that has those little invaginations or curves called cristae. And in the matrix is the material that is composed inside that inner membrane, and it performs many important vital functions. The final stages of your food breakdown, believe it or not, go through the process of energy conversion inside the mitochondria to actually make the end product called ATP, or adenosine triphosphate. Mitochondria are very, very unique in the fact that they contain their own DNA, and the majority, or 100% of the DNA in mitochondria, is actually inherited from your mother.
That is fascinating, and we'll talk about that in a future episode. There's actually 37 DNA in the mitochondria, which is really a cool thing, but nonetheless comes from the mom only, and we don't know why. You can look and study it, but nobody really has an explanation. I'm sure there probably is somewhere. But think about the mitochondria, the powerhouse of the cell. It's not the largest organelle. The largest organelle inside the cell was the nucleus, but these powerhouses give everything that we are the fuel to make our cells operate, to make us live. When we stop getting ATP production, which is actually what we produce in those mitochondria, those organelles, we start to die. That's the way that is. So this is where the final step of this food breakdown to energy takes place. Much more to come on that at a future day coming up soon. But we wanted to break down that for you. The mitochondria is so critical to the life, and it's like having the gasoline manufacturer, like a refinery within the cell, isn't it? It produces energy on demand. That's cool. The more energy you need, mitochondria will even grow. They will get bigger. They will expand. They'll go through a growth spurt. Isn't that kind of cool? If you don't use them, they'll also die as well. So think about that the next time you think about the cell and the functionality of the body. So we transfer from the mitochondria, and now we're going to get into this wild thing called the endoplasmic reticulum. What a big word. What does that look like, and what is it? Here's a picture right now.
So take a look here. You see that pink squiggly lines there that's got these dots on it? Well, that's the rough endoplasmic reticulum, and we know that the rough endoplasmic reticulum is very involved in the transcription, translation, and production of proteins. And the smooth endoplasmic reticulum will receive those end products and then process them to then send them on to this thing called the Golgi apparatus.
So you see there those ribosomes that are on the rough, and when the little orange dots, right? And once they've been off of there, that becomes the smooth endoplasmic reticulum. So it makes it rough, the little orange dots, obviously. Now we have to understand this endoplasmic reticulum is more than just a bunch of squiggly lines. Oh, it's so much more than that. What does it do? It has a ton of unique, amazing functions.
Well, as it sits right next to the nucleus, those little invaginations, that pink stuff, the rough endoplasmic reticulum, has ribosomes attached, which are the conversion process, the translation and transcription of messenger RNA that comes from the nucleus to make cellular components, tissues, and organs to help you become an organism. The smooth endoplasmic reticulum actually contains enzymes that also are very important in the detoxification system called the CYP450 system. And they also produce compounds like your steroid hormones, and they're involved in metabolisms of certain drugs and other toxic chemicals. So the endoplasmic reticulum is very important in screening your environment. In the rough endoplasmic reticulum, it's also involved in the translation of certain types of proteins, and it is because the attachment of those ribosomes to their membranes give it that application.
Hence, the rough appearance, right? Isn't that crazy? The fascinating thing we just talked about, many of you heard a term, messenger RNA. This is where the whole mRNA technology really affects. It's the relationship between the nucleus, the DNA, and then the mRNA that's sort of transcribed there within the endoplasmic reticulum. Pretty cool, isn't it? Where these proteins are synthesized. So this instruction that is given in some of this mRNA technology is telling the body what proteins to synthesize. Pretty cool. So hopefully you kind of got how that works. So the endoplasmic reticulum is a busy guy. Now, what also is in the cell that's crazy, and we forget about this in biology class, is this thing called the Golgi Complex. What is that? This thing looks like some kind of sea creature. Check this out.
Well, in the Golgi apparatus, it sits off of the side of the endoplasmic reticulum. You can see there that it's got a cis face and a trans face. And as the cis face is it's bringing in incoming transport vesicles. It goes through a process of screening and understanding inside the Golgi apparatus. And then that transphase, it allows for these secretory vesicles to then be released into the cytoplasm to either be used by the cell or transported out of the cell.
So the cis face is the receiver. The trans face is the pro-communicator. Isn't that cool? The cis receives and the trans gives on, right?
It's so amazing how all of this occurs down at the cellular level.
I know, you think about only God could create this. There's no way around it. Now, when we talk about this Golgi apparatus, Golgi Complex, it has a lot of functions that we just talked about just a moment ago, but a little more detail is right here.
The Golgi receives proteins produced by the ribosomes, and it modifies these proteins in this rough endoplasmic reticulum and distributes them to other regions of the cell, or it moves them outside the cell like we talked about. And as these vesicles are released, they may travel to the cell membrane where they actually become part of the membrane, or they're exported out of the cell. Golgi vesicles also carry certain proteins which were synthesized by the rough endoplasmic reticulum, and they can become part of other cell organelles called the lysosomes.
The lysosomes, well, think about those. The lysosomes have a really cool functionality too. I think they're probably the underappreciated child of the cell. So what does a lysosome look like as we kind of wrap up our last basic little organelle description of the cell? What does a lysosome look like? There it is.
It's a little green dot inside that cell that's got its own cellular membrane. And you see there's all kinds of stuff housed inside that lysosome. Lysosomes are cytoplasmic organelles similar in size to the mitochondria. Remember that jelly bean-shaped thing we talked about? They're involved in intracellular digestion. They're enclosed by a single membrane that contains pumps that maintain an internal pH. And this pH allows for the digestion of all kinds of things that need to be degraded on the inside of the cell. It's like damaged material that needs to be taken care of, because our cells go through a process of stressors, cleanup, reorganization every single day. So the products of lysosomal digestions are actually returned to the cell cytosol, and they're recycled components of the cell that can actually be reused. So lysosomes are kind of like a recycling factory inside of your every single solitary cell in your body.
Love those lysosomes, and I hope you caught the idea of that. There is a pH inside the cell that's acidic. Isn't that kind of cool? 5 is acidic. Remember, about 7 is going to be kind of 7.23, and then above that's going to be alkaline. Below that's going to be acidic. Isn't that fascinating? So, well, we're going to get back to our Kingdom Fuel, and we'll let you get back to your night. Hopefully you've enjoyed this. Next week we'll review quickly the lysosome. We'll pick back up with something called the cytoskeleton. Hello. Look forward to that next week.
And keep this in your mindset that all of these cellular components are driven by essential proteins, essential fatty acids, essential nutrients, vitamins, and minerals that keep the cell healthy and alive. Kingdom Fuel.
All right. Catch you next week.
Doctors Mark and Michelle Sherwood and their clinic can help you find the hope and health you were created to enjoy. Go to Sherwood.tv for clear, proven ways you can be healthier. Subscribe at Sherwood.tv